Ever wondered if the universe as we know it might be a mere blink in an infinite electrical cosmos? Imagine, if you will, a universe that flickers in and out of existence, its fundamental forces dancing to the tune of an unseen conductor. This is not the stuff of science fiction, but a radical new principle called Analog-QAM, or quantum amplitude modulation. The Analog-QAM principle suggests that the four fundamental forces of the universe, gravity, electromagnetism, and the strong and weak nuclear forces, are not constant. Instead, they vary in small, discrete time intervals, akin to the universe blinking on. This perspective stems from an intriguing conceptual framework known as the electrical universe. In the electrical universe, conventional notions of distance and motion are eliminated. Instead, the universe is considered from the viewpoint of a single point, leading to a profound unity among the forces that become apparent in this model. This idea extends Newton's laws of motion into a broader, possibly multidimensional or non-dimensional context. But it doesn't stop there. This proposed principle also introduces a unified force equation, where the vector sum of all four fundamental forces equals 0 for a mass or particle at rest. Furthermore, it presents a new interpretation of energy, equating joules with the product of electrical mass, volts, and range, amp*sec. The implications of this principle are mind-boggling. It challenges our conventional understanding of physics by suggesting that the fundamental forces vary over discrete time intervals. This implies that our understanding of these forces as constants might be an oversimplification due to time averaging and experiments. In the forthcoming scenes, we will delve deeper into the Analog-QAM principle and the electrical universe model. We will explore theoretical explorations, mathematical formalisms, experimental verifications, and the integration with existing theories. We will also ponder philosophical and conceptual considerations that this idea opens up. Join us on this scientific exploration as we delve into these intriguing proposals. Imagine, if you will, a universe where the four fundamental forces are not constant, but vary in small, discrete time intervals. This is the concept at the heart of the Analog-QAM principle, a revolutionary idea that challenges conventional perspectives of the universe. Here's a new proposal for you. Instead of seeing the fundamental forces, gravity, electromagnetism, strong and weak forces, as constants, we consider them as variables, oscillating subtly in a way akin to the universe blinking on and off. This idea stems from the electrical universe model, suggesting a broader, possibly multidimensional or non-dimensional context for understanding these forces. Now let's delve a bit deeper into this concept. The proposal introduces a unified force equation, where the vector sum of all four fundamental forces equals 0 for a mass or particle at rest. This equation extends Newton's laws of motion, offering a profound unity among the forces. It's as if these forces, seemingly distinct and separate, are but different expressions of the same phenomenon, becoming apparent only under the lens of the electrical universe model. But what does this mean for our understanding of the universe? Well, if this principle holds, it implies that our perception of these forces as constants might be an oversimplification. Perhaps, due to time averaging and experiments, we have missed the subtle variations that occur over discrete time intervals. It's like listening to a symphony and missing the subtle variations in the notes due to the grandeur of the music. This principle, if validated, could represent a paradigm shift in our understanding of the universe, challenging and expanding upon the current frameworks of physics. It takes us a step closer to unifying the seemingly disparate elements of the cosmos, offering a new way to interpret the fundamental forces and masses as two aspects of the same phenomenon. A universe blinking on and off, you might say. An intriguing thought, isn't it? Now let's journey into the concept of an electrical universe, a universe with 0 dimensions. In this model, the universe is conceived as a single point. This may seem counterintuitive, as we are accustomed to thinking in terms of space and time, of distances and durations. Yet, in the electrical universe, these familiar concepts are absent. There is no distance, no motion. The universe appears to be static, yet it is anything but. One of the key properties of the electrical universe is the existence of a fundamental carrier wave. This wave, though it does not travel through space or time as we understand them, carries the information that gives rise to the universe we perceive. It is like a cosmic radio signal, broadcasting the code of reality. In this model, the fundamental forces and masses are seen not as separate entities, but as two aspects of the same phenomenon. They are the expression of the carrier wave in the universe. In other words, everything we observe, from the smallest particle to the largest galaxy, is a manifestation of this wave. This conception of the universe has profound implications for our understanding of the fundamental forces. In the electrical universe model, the four forces, gravity, electromagnetism, and the strong and weak nuclear forces, are not constant. Instead, they vary in discrete time intervals, like the universe blinking on and off. This is a radical departure from traditional physics, which views these forces as unchanging and eternal. The electrical universe model also introduces a new interpretation of energy. Energy, rather than being a quantity in its own right, is seen as the product of electrical mass and range. This offers a new way of understanding phenomena within the universe, bridging the gap between the microcosm of quantum mechanics and the macrocosm of relativity. A universe without distance or motion, yet capable of creating everything we perceive. A fascinating concept indeed. Scene script. How can we test these ideas? And what does energy look like in this electrical universe? To validate this model, the proposal suggests experimental tests focused on detecting variations in the fundamental forces over discrete time intervals. This is a departure from the norm, as typically we observe time average values in laboratory conditions. Imagine if we could capture these minute changes, these tiny blinks of the universe. We'd be looking at a whole new way of understanding the very fabric of reality. The experiments would require high-precision measurements, capable of capturing these incredibly short-lived phenomena. It's a bit like trying to capture a hummingbird in flight, where every wing beat could hold valuable data. It's a daring and ambitious task, but one that could potentially change our understanding of the universe. Now, let's turn our attention to energy within the electrical universe. The proposal introduces a novel interpretation of energy, equating joules with the product of electrical mass, volts, and range, amp*sec. This equation may seem a little unfamiliar, but it's essentially a new way of understanding energy, one that could provide a framework for interpreting phenomena within the electrical universe. Think of it as a new language, a new vocabulary to describe the universe. Just as a poet uses words to depict emotions and experiences, this equation uses volts and amp*sec to describe energy. It's a language that could help us unravel the mysteries of the universe, a language that could potentially redefine our understanding of energy. Remember, these are just proposals, ideas that need rigorous testing and verification. But that's the beauty of science, isn't it? We're always pushing the boundaries, always questioning, always exploring. Every new theory is a potential game changer, a possible key to unlocking the secrets of the universe. Testing new theories is always a thrilling endeavor, pushing the boundaries of our knowledge and understanding. So where do we go from here? What are the implications and next steps of this intriguing proposal? Let's start with theoretical exploration. This proposed principle challenges traditional physics by suggesting that the fundamental forces vary over discrete time intervals. It implies that our understanding of these forces as constants might merely be a simplification due to time averaging in experiments. This presents a new frontier for theoretical physicists to delve into. Next, we have the mathematical formalism. Crafting a rigorous mathematical framework to describe these phenomena is critical. This includes formalizing the equations mentioned in the proposal and exploring their implications for quantum field theory, general relativity, and beyond. We're talking about a potential revolution in the language of physics itself. Then comes experimental verification. Designing experiments to detect the predicted variations in the fundamental forces over discrete time intervals is essential. This may involve high-precision measurements and the ability to capture extremely short-lived phenomena. In a way, we're setting the stage for a new era of experimental physics. Integration with existing theories is another fascinating aspect. We need to explore how this new principle integrates with or modifies existing theories, like quantum field theory and general relativity. This involves understanding the implications for particle physics, cosmology, and the very fabric of space-time. It's like attempting to weave a new thread into the grand tapestry of our scientific understanding. Lastly, we have philosophical and conceptual considerations. The idea of an electrical universe, with its implications for the nature of reality and the unity of forces, opens up philosophical inquiries into existence, the structure of the universe, and the limits of human comprehension. It's a call to philosophers and thinkers alike to reevaluate our understanding of the cosmos. We stand at the frontier of a potentially paradigm-shifting perspective, ready to explore the uncharted territories of our universe. So, we've journeyed through the thought-provoking ideas of the Analog-QAM Principle and the electrical universe model. We've seen how these proposals challenge conventional physics, suggesting that the fundamental forces of the universe may vary in tiny, discrete time intervals, as if the universe is blinking on. We delved into the electrical universe model, a zero-dimensional universe that births a fundamental carrier wave, supporting all universes. It reframes our understanding of the fundamental forces and masses, viewing them as two sides of the same coin. We also explored the unified force equation, an intriguing proposal that extends Newton's laws of motion into a potentially multidimensional or non-dimensional context. This equation suggests an underlying unity among the forces that become apparent in the electrical universe model. We discovered a novel interpretation of energy in the electrical universe, where energy, measured in joules, is equated with the product of electrical mass and range. This provides a fresh framework for understanding phenomena within the electrical universe. We've considered the theoretical implications of these ideas, recognizing that they challenge our current understanding of the fundamental forces as constants. We've also discussed the need for a rigorous mathematical formalism to describe these phenomena, and how this new principle might integrate with or modify existing theories, such as quantum field theory and general relativity. We've highlighted the importance of experimental verification, designing tests to detect the predicted variations in the fundamental forces over discrete time intervals. Lastly, we've pondered the philosophical and conceptual ramifications of an electrical universe. This new viewpoint opens up inquiries into the nature of existence, the structure of the universe, and the limitations of human understanding. These proposals, if validated, could represent a seismic shift in our comprehension of the universe, challenging and expanding upon the current frameworks of physics. As we continue to explore and question, we keep reshaping our understanding of the universe, one blink at a time.